how to convert between effective rate and nominal rate of interest. So we have a nominal annual interest rate of 24% compounded monthly is equivalent to an effective annual rate of interest of 26.82%. So let's assume that we don't know the effective annual rate of interest. So we have the nominal annual interest rate of 24%, compounding frequency of monthly, 12 a year. So we press second icon V. Okay, you can see the norm appears, and then 24. Enter to key in the nominal rates, and then down, CY appears. Okay, 12. Enter to key in the number of compounding periods, and then down, EFF appears. CVT to compute the EFF, to compute the effective annual rate of interest. So how about we assume that we don't know the nominal annual interest rate. Okay, let me second clear TVM and second clear work to clear the things first. Okay, and then we start again. Second icon V. Okay, now we don't know the nominal annual interest rate, so we down, EF appears. We don't know the EF, so 26.82. Enter to key in the effective annual rate of interest, and then down, CY appears. 12. Enter. This is the number of compounding periods, and then down, NOM appears. Okay, we press CBT to compute. Okay, we get our nominal interest rate. So how to obtain the present value and future value for immediate annuity? So this is our question. What is the present value of payments 250 make at the end of every quarter for 12 years if interest is 7.5% compounded half yearly? So before solving a problem, we press second clear TVM to clear the time value of money entries. Okay, so how to solve our question by using calculator? So we have payment interval quarterly 4 times per year, and compounding frequency half yearly 2 times per year. So we second PY. Okay, PY appears. So we 4 enter to key in the payment interval, and then press down, CY appears, and then 2 enter to key in the compounding frequency, and we second quit. Okay, so 48, and this number of payments, and 7.5 key in the interest. Okay, 250 negative, and key in the payment. Okay, since the future value is not given, so we assume that it is 0 FV. So we CBT to compute PV. Okay, we get our PV. Okay, the next question. What is the future value of payments 400 make at the end of every month for 5 years if interest is 3.2% compounded monthly? So before solving a problem, also same, we press second clear TVM to clear the time value of money entries. So we RCL can refer back. Okay, all is 0. Okay, okay. So we also do the same thing. The payment interval monthly 12 times per year, compounding frequency monthly 12 times per year. So we second PY. Okay, we see the PY appears. 12 enter to key in the payment interval, press down, CY appears. Okay, 12 enter to key in the compounding frequency, again second quit. Okay, 60, and this is our number of payments, 3.2 IY to key in the interest, 400 negative payment to key in our payment. Since the present value is not given, so we assume that it is 0. Okay, so CBT FV, okay, we get our future value. So how to obtain present value and future value for annuity due? Okay, what is the present value of payments 300 made at the beginning of every year for 10 years if interest is 5% compounded yearly? So the same step. Before solving a problem, we second clear TVM to clear all the time value of money entries. So to solve the question by using calculator, we have payment interval yearly, 1 time per year, compounding frequency yearly, 1 time per year. So to solve the annuity due problem, we should change our mode into begin mode. So we have second BGN, second set, second quit. Okay, you can saw this BGN appears. So this indicate that we are in begin mode. So second PY appears, 1 enter to key in our payment interval. Again, press down, CY appears, 1 enter to key in our compounding frequency. Okay, second quit. Okay, 10 N to key in the number of payments, 5 to key in the IV to key in the interest, 300 negative to key in the payment. Okay, since the future value is not given, we assume that it is 0. Okay, CBT PV. Okay, we get the present value. So next, how to find the future value? The question is given the future value of payment 400 made at the beginning of every month for 5 years if interest is 4.2% compounded quarterly. Okay, the same things. Second, clear TVN to clear all the time value of money entries. So we have payment interval monthly 12 per year and compounding frequency quarterly 4 times per year. Okay. We are already in begin mode, so we can skip this step, which will turn our into begin mode. So we skip this step. Second, PY. Okay. 12. Enter to key in the payment interval, and then press down. 4. Enter to key in the compounding frequency. Again, second quit. Okay. 60. N to key in the number of payments. 4.2. IY to key in the interest. 400 negative to key in the payment. Since the present value is not given, we assume that it is 0. So CBT future FV. Okay, our future value is computed.
Okay, good evening, Dr. Kaur. I'm Wei Chan and my matrix number is 17205294/1. So I'm going to present question 1B3, which is to find the present value of increasing present value and future value of increasing annuity, which is denoted by bracket IA, bracket angle N, and bracket IS, bracket angle N. Okay, so we assume that this is the payment lah. Okay, so it's pay in arrears. So at time 0 pay nothing, time 1 pay $1, time 2 pay $2, time 3 pay $3, time 4 pay $4. So we need to find. Okay, so we start off with pressing CF. Okay, CFO we clear first, second, and then clear. CFO is equals to the time 0. What is the cash flow? Okay, we press CF to initiate the cash flow worksheet. So okay, so CFO is equal to 0 lor. So we go down. Okay, press enter. Okay, remain lah. We go down. CO1 is equals to 1. We press enter and then we go down. F for every frequency in the increasing annuity is equals to 1 because we pay the annuity in one time only for the amount, each amount. So at the next time of payment we will pay more. Next time we pay more. So each payment is pay one time only. We won't pay $1 twice. That is the reason lah. Okay, so we go down to CO2 to enter, go down. FO2 1 remain, go down. CO3 3 enter, go down. FO3 1 go down, remain. Okay, CO4 4 enter. So we press MPV. Okay, I is the interest rate, which is 6%. We press 6 and then enter. Okay, and then we press go down. MPV we press compute. So we get 8.4106, which is the present value. Okay, so we need to find the future value. We times with I plus 1 plus I to the power of n. Okay, so 1 plus I is 6%. So 1 plus I is equals to 1.06. So we times bracket 1.06 bracket to the power of n is equals to 4, and then enter. Equal. So it's equals to 10.6182. Okay, so I'm going to present question 1b4, annuity payable PILI. We assume that the annuity is paid in arrears, which is at the end of period. So we need to find the present value and future value, which are denoted by A bracket P angle N and S bracket P angle N. So the let's say the annuity payable is paid half yearly, number of years is 20, effective interest rate is 12%, payment per annum is 200. Okay, so we press second IY, it becomes PY lah. So PY stands for the payment per year. Payment per year, 1 year is the annuity is paid half yearly ma. So 1 year you 1 half year you pay 1 time, 1 half year you pay 1 time. So 1 year you pay 2 times. So PY equals to 2, and then press enter, go down. CY is the interest compounded per year. So the interest is compounded 1 time 1 year only. So it's equals to 1, and then press enter, and then we press CIC to go out. Okay, and then we need to determine the number of the N. N is number of period. You got 20 years, but then you pay half yearly. Okay, half yearly. So 1 year you got 2 period ma. So 20 times 2 equals to 40. Okay, and then we press N. N equals to 40. Then the interest rate is 12%. So we press 12 and then press IY. Okay, the payment per period is 100. Why? Because payment per annum is 200 ma. So you got you pay half yearly. So 1 year you pay twice. So payment per period is 200 divided by 2 equals to 100, and pay and press PMT. And then you press compute. You get your PV. Okay, compute PV is your present value. Present value is 1537.4360, and then this is your present value. Then you have to multiply by this to get future value. So I is equals to 12%. So 12% equals to 0.12. So is 1 plus 0.12 equals to 1.12 to the power of n. N is 20 because the I is effective interest rate per annum so the n has to in per annum no. Okay, so you need to times 1.12 to the power of 20 equals to this one, your future value. Okay, so now I'm going to present question 1C. Any other tips on BA2 plus calculator? So I have the question over here. Consider a project with the following expected cash flows. Okay, year 0, negative $5,000. Year 1, $1,000. Year 2, $1,500. Year 3, $4,000. Okay, so if the discount rate is 5%, what is the project's net present value NPV and the internal rate of return IRR? So okay, first we press CF first. Okay, to initiate the cash flow worksheet. Okay, so we press second and then clear all of things. Okay, CFO is the at time 0, what is the cash flow? Okay, it's negative 5,000. So we press 5,000 and then we press negative and then press enter. Okay, we goes down. CO1, year 1. Okay, year 1, what is the cash flow? 1,000. Press 1,000, enter, go down. FO1 is equals to 1. Why? Because we obtain 1,000. We have in cash flow in positive cash flow 1,000 for one time only. We don't have many times of 1,000. Okay, so CO2 1,500. Enter, go down. FO2 is also equals to 1. Okay, go down. CO3 4,000. Enter, and then we have so we press NPV. I is equals to the discount rate, so it's 5%. So we press 5, enter. Okay, so we press down. Okay, NPV we press compute, which equals to 768 2.2756. Okay, when it is greater than 0, is positive, then we accept the project. Okay, so how are we going to find the IRR, internal rate of return? We press IRR and then press compute. Is equals to 11.3976. When it's greater than 5%, okay, this is in percent lah. So when it's greater than 5%, then we accept the project. So that's all from me. Thank you.
Hello, doctor. I am Chong Jing Heng, and I'm going to explain the question 2a. Let's say we are given I, which is the effective rate of interest equal to 10% or 0.1. We are able to find the IP and DP, which is the nominal rate of interest and discount convertible period. By using these two formulas, which are IP equal to P times 1 plus I power 1 over P minus 1 and dP equal to P times 1 minus bracket 1 minus D power 1 over P. And we let P equal to 1, 2, 4 and 12. 2 mean convertible half yearly, 4 mean convertible quarterly, and 12 mean convertible monthly. So I1 is just the effective rate of interest, which is equal to 0.1. For I2, we use the formula, which is 2 times 1 plus 0.1 power 1 over 2 minus 1, and we are able to get this answer. Same thing go with I4 and I12, which are the interest rate convertible quarterly and convertible monthly respectively. So for discount rate, D1 is just the effective discount rate, which we use the formula IV, which is equal to 0.1 over 1 plus I, which is equal to 1.1. And for D2, we just use the formula, which is 2 times 1 minus bracket 1 minus D power 1 over 2, and we are able to get this answer. By using the same formula, we are able to solve the D4 and D12. And finally, for delta, we use the formula ln 1 plus I, which is equal to ln 1 plus 0.1. So we are able to get this answer, which is equal to 0.09531. And that's all for me. Thank you.
Hi Doctor, I'm Lim Kim Yong and I'm going to present question 2B1. So question 2B1, immediate annuity, I choose to do the present value of it, that is A angle N. And for the first part of the question, we are asked to find the function of immediate annuity on I. So the I from 0.01 increased by 0.001 to 0.5. Here is it. And then next, I need to fix two variables, that is the payments and the number of years. I fix it to be 10 and 100 respectively. And the immediate annuity, the formula is here. Then I key in the formula and multiply by the payments. So this is the formula 1 minus 1 over, and this bit is V and this is N, and the whole thing divided by I. So this is how I do it, and then I just pull it down and I get this value. After that, I can get the graph something like this, the graph of immediate annuity against interest, that is A angle N against I. So as we can see, when I increases, A angle N decreases, and the reason is because as we can see, when the denominator here increases, the value of A angle N will be decreases because their relationship is inversely proportional. Okay. So for the second part, I'm going to present the function immediate annuity on N. So this time the number of years will be the changing variables. So as requested in the question, the number of years increased from 1 to 30. Then another two variable that I'm going to fix is the payment and interest. So payment here I fix it to be 100 and the interest I fix it to be 0.05. Then the same way, here is the formula I key in. Here, this bit here is actually V and this is N. So 1 minus V power N over I, that is the interest, then multiply by the payment, then I will get this, and I pull it down and I will get the data like this. So to be more clear, this is the graph of immediate annuity against number of years, that is the graph of A angle N against N. Because I choose to do the present value of immediate annuity, so this is the shape of the graph. Why it is different from the previous one? It is because, as we can see, when N increases, A angle N actually also increases. So the relationship between them is directly proportional. So when N increases, A angle N will also increases. So that's all from me. Thank you.
Hi doctor, I'm Chang Xiang and I'm going to present question 2, part B, annuity yield. First, we let annuity yield be a function on I, where I increases from 0.01 up to 0.5 with a step size of 0.001. So column C here is our list of interest that starts from 0.01 up to 0.5 with a step size of 0.001. Then we fix our number of years is 10 and our payment is 100. After that, we can key in our equation for annuity yield. So we know that our formula for annuity yield is our payment here, B2 multiplied by 1 minus V to the power of N, where the V is 1 plus I, our interest here, to the power of negative N, where N is our number of years here. Then we bracket, then we divide by D, where we know that our D is equals to I might multiply by V. Then our I is interest here, multiplied by V is 1 plus I to the power of negative 1 bracket. After that, we can press enter and we can get our value here. So column D here is our list of the value of annuity yield based on the different interests here. From the data here, we can also construct a graph where it is annuity yield against the interest. As we can observe here, we can know that as the interest increases, the annuity yield will decreases. This is because when the interest is higher, when we discount back to the present value or when we want to find the annuity yield, the value also definitely will be lower due to the higher interest. Next, we proceed to our next part where we let the function annuity yield on the number of years, where the number of years increases from 1 up to 30. Then we fix our payment is 100 and our interest is 0.05. Then we also key in the equation for annuity yield as same as the previous one, which is the payment multiplied by 1 minus V to the power of N, where the V is 1 plus I here to the power of negative number of years, divide by D, where the D is I multiplied by V, the I is our interest here, multiplied by 1 plus interest to the power of negative 1. Then when we press enter, we can get our list of annuity yield here based on the different number of years. From the data here, we can also construct a graph where the graph is the annuity yield against the number of years. Here, as we can observe that when the number of years increases, the annuity yield also will increases. This is because time value of money. When it's longer time or when the number of years increases, the accumulation of our money also will increases. So when we discount back or when we find the annuity yield, the value also should be higher. So that's it. Thank you.
Good evening, sir. So I'm Yo Zong Hong. I will be presenting for the question 2, increasing annuity part. So here we have column A, number of years N, we set as 10, and then column B, first payment P, we set as 100, and column C, increase per annum for the payment. Every year we increase by 10, and then the interest rate we set as 0.01, increase until 0.5 with a step size of 0.001 here until 0.5, yeah. And then for the increasing annuity, we have this formula here, which is derived by this formula here. So the increasing annuity formula is P minus Q times N plus Q times increasing annuity. So we can further elaborate this formula into terms of NPQI. So it's P minus Q times 1 minus 1 plus I bracket power of -1 over I plus Q times 1 minus I plus 1 power of -1 divided by I times 1 plus I power of -1 minus n times 1 plus I power of -n divided by I. So this formula we just substitute, we just type out this formula here into the formula bar and substitute all these values inside, then we get the value of increasing annuity. So we can see from the graph here, where we input this data into the graph, you can see that the increasing annuity decreases when interest increases. So this because we can see we know that the future value equals to present value times the 1 plus I power of n number of years. So whenever the interest increases, the present value always decreases. Yeah. So we move on to the number of the one that we alter the number of years n. So for column A, we have number of years n, which we increase the number of years from 1 to 30, and then the column B for first payment P, and then column C increased by annum Q, and then D interest I, which is set on 0.01. So the formula is the same one as before. So you can see here from the graph, when we input the data inside, you can see that when the number of years increases, the increasing annuity also increases. So this is because of time value of money. So when the period is longer, the present value always increases. Thank you.
First, we let the nominal interest rate equal to 0.01. In this case, we can use Formula 1 to calculate the nominal interest rate per semester is about 0.009975. Let the period be equal to 10 years and paid 100 every 6 months. Formula 3 can be used to calculate the final value of the arranged annuity when the capital paid in each period is 1. Then use Formula 2 to calculate the final value of the annuity for a period of 10 years if 100 is paid in each period. The result of different interest rates are as shown in annuity payable half yearly in arrears. It can be seen from the graph that as interest rates increase, the final value of annuities continues to increase. So, first, we let the nominal interest rate equal to 0.05. In this case, we use Formula 1 to calculate the nominal interest rate per semester is about 0.04939. The payment time ranges from 1 year to 30 years. Formula 3 can be used to calculate the final value of the arrears annuity when the capital paid in each period is 1. Then, use Formula 2 to calculate the final value of the annuity from 1 to 30 years if 100 is paid in each period. The result of different interest rates are as shown in annuity payable half yearly in arrears. It can be seen from the graph that as the payment time increases, the final value of the annuity continues to increase.